and t is just a constant. Now, when this operator acts on the different terms, the Hamiltonian is simply going to become the eigenvalue of that given state. But remember that E0 is smaller than E1, is smaller than E2, etc. And so if I take t to be large, then this first term is going to be the one that is least suppressed, and all the subsequent terms are going to be highly suppressed compared to the first one. And so by taking t to infinity, this operator, in a sense, acts as a projector onto the ground state, onto some normalization factor. So what does this have to do with path integrals? Remember that the path integral gives you the transition amplitude, starting with some initial state phi I at time ti, to transition to some final state phi b at some final time t final. And you might ask, well, why are you calling this phi b? And you're going to see that eventually this amounts to being the boundary value of the field. But just imagine it for now as just some final state. And I notice that if I take my initial time to go to I infinity, then the evolution operator acting on the state phi I becomes this projector operator in some sense that I considered in the previous slide. And so by taking ti to I infinity, I am computing, in a sense, the ground state wave function of this theory. And I want to make a couple of comments on boundary condition. Oh, and so what I want to say is that instead of integrating ti over the imaginary lines at I infinity, I can consider doing a Wick rotation so that I'm integrating over tau, and now I'm integrating tau over the real line from negative infinity to some tau final, and my wave function is going to be a function of tau final and the final field value. And so this amounts to computing an Euclidean path integral because of the Wick rotation. In the end, I have to remember to Wick rotate back. And what I want to point out is the boundary conditions that I'm imposing on my path integral. I'm going to require that at time tau final, my field has to have value phi b. And then when it comes to the negative infinite tau, I'm simply going to require that my field is well behaved, that it's not diverging.